In today's video, I will share a secret repair technique with you that no one else will tell you about. This issue is quite rare, and whenever it arises, it becomes difficult to fix. Since I have already detected this problem, I will share the solution with you today. This is the circuit board of the indoor unit, and similarly, this is the circuit board of the outdoor unit. The issue with these boards is that they are both showing the F1 error. When an F1 error appears on these boards, it means there is a serial communication error. A serial communication error signifies one of two things. Either the outdoor circuit is completely damaged or faulty, which could cause this problem, or the indoor unit is functioning, but its communication circuit has an issue. The communication circuit is located in this area, starting here and extending to this red wire. If there is a problem within this section, the F1 error will appear. Similarly, if the outdoor unit is working, but its communication circuit develops a fault, this can also result in the same issue. Sometimes, it happens that the wire connections between the outdoor and indoor units get affected. I have made these connections with the indoor unit. If any of these wires get cut, or if a wire burns out, the F1 or serial communication error can still occur. However, at the moment, both of these PCBs are functioning properly, and their communication circuits are also working perfectly. But sometimes, the F1 error still appears unexpectedly. What happens is that the PCB might work fine for half an hour, or sometimes it might work for hours without any error. Then suddenly, the error appears, and just as suddenly, it disappears. This kind of fault becomes difficult to detect, so today, I will reveal the whole secret to you. Now, I have securely removed the IPM board from the cover. Let's talk about its issue. The LED sometimes glows and sometimes doesn't. When the LED doesn't glow, it is a clear indication that the board is faulty. Another sign is when the LED glows faintly at times. This too indicates that there is a problem with this board, and sometimes the LED might glow even brighter. But the most likely issue is that the problem lies with this board. In this situation, it happens that when you remove and check all the parts and components, you may not see any issues with them. So, where does the problem actually lie? The issue is with this voltage regulator. It's a 5-volt voltage regulator. When it heats up, the problem arises. It heats up and then short circuits. Let me show you where it short circuits. Because if you remove this part from the board and check it, it will appear perfectly fine with no issues. Even if you use it on another board, you won't find any problems with it. But despite all that, it still short circuits, and I'll tell you exactly where that happens. I have also noticed that whenever this board goes bad, people completely replace it. Now, to explain this problem further, I will need to desolder the voltage regulator so I can show you exactly which point it short circuits from. To quickly desolder any component, the first step is to add a new solder to it. This is a good practice as it helps desolder the component more easily. Now, we've removed it from the board. If we test this voltage regulator normally, it will appear to be perfectly fine with no issues. So where does the problem occur? Let me show you. The issue lies with the heatsink attached to it. This heatsink short circuits. These prints underneath, where the heatsink is mounted, are the problem areas. The heatsink gets shorted with these prints, causing the voltage regulator to stop working. And when the voltage regulator stops working, the entire PCB also stops functioning. To fix this issue, I will take steps to protect it, and I'll show you how I do that. To protect this area, I've cut a piece of insulating material. I've marked 3 specific points on the insulation paper. Now, I'll make holes in the insulation paper to align with the pins of the regulator. There's the first hole, the second, and the third. Now, I'll insert the regulator's pins through these holes. Perfect. To conceal the repair, I'll trim the excess insulation from the corners. The insulation piece fits perfectly. I'll adjust the front alignment a bit. This side needs a little more adjustment. The cleaner this job is done, the more secret this repair will remain. No one will be able to detect it. Now it's completely hidden. It's like a protective cover. The insulation won't interfere with the circuit. I'll reinstall the component. No one will notice the modification. The fault, specifically the F1 issue, is now resolved. Even if you zoom in, the repair is invisible. I've soldered the connections. The PCB is fully functional. I've powered it on, and there are no issues. Click on the left or right thumbnail to watch our next videos. And subscribe. Thank you.